If you took an air-filled balloon and put it in a vacuum chamber and then evacuated the chamber, what do you think would happen? Let's just see. The balloon expands so that we see that as we decrease the pressure on the balloon, its volume increases, and vice versa. Which then leads us to another question. Is there a quantitative relationship between increases and decreases in pressure and increases and decreases in volume? Okay, so maybe you weren't led to that same question. You probably already know the answer. But stick with us for this investigation, because we're going to do something a little bit different with manual sampling. And you will have the opportunity to get some more practice using the calculator and creating new graphs. So here's the game plan. We have here this absolute pressure sensor and syringe and tubing and connectors that come packaged with it. We are going to use the plunger on this syringe to vary the volume of air inside of it, starting at 20 milliliters and stepping down 2 milliliters at a time to 6 milliliters. And while we do this, we are going to measure the resulting changes in pressure with the sensor. If you're going to do this activity with us, the setup is very easy. All you need to do is cut off about a centimeter of the tubing, put one end on the syringe and one of these quick connects on the other end. Pull the syringe out to 20 milliliters and then connect it to your pressure sensor. And then you're ready to connect the sensor to the Explorer GLX in one of these top ports. But I am going to use this passport extension cable so that we can provide you with a better view of the procedure. So let's connect it. And when we do, we see that the Explorer GLX opens with a graph display of pressure versus time. But remember the game plan. We are interested in seeing how the pressure varies with volume. So before we can proceed with our plan, we need to tell the Explorer GLX two things. First, that as we step down the volume on the syringe, we want to record discrete data points from the sensor. And second, that we want to be able to type in the volume with each step and associate it with the corresponding data point from the pressure sensor. Okay, recall from a previous activity, we took a pH sensor and put it in a household chemical, told the Explorer GLX to record a single data point, labeled that data point with the corresponding chemical name by typing it in via the keyboard or keypad, whichever you happen to have at the time. Well, this is similar to what we need for our activity here. Only the difference is, instead of associating or labeling a chemical name like we did with the pH sensor, we want to associate a value, a number, the volume of the syringe. So, to be able to do that, we need to change the sampling mode of the Explorer GLX. Remember what it's called? It's the one with the flag. It's called manual sampling. To get to manual sampling, we need to go to the sensor screen. To go to the sensor screen, we need to go to our home screen first, and then push F4 to get to the sensor screen. Now you remember here we can change the sample rate, but we can also change the sample mode, which you can access through the F1 button. And here we have a menu of the ways that we can sample. Item number 2, flagged for us, is manual sampling. Let's select it. Soon as you do, a new screen opens up, data properties. And if you look at the measurement name for that data properties, it's keyboard data, or in our case, keypad data. This is where we tell the Explorer GLX that we want to enter volume via the keypad. So let's change the name of that measurement to volume. And you might recall that to type in text, first thing we need to do is push the check mark so that we can edit that field, and then use the keys with the letters on them by pushing them successive times until we cycle through to the letter that we want. And then when you pause, the cursor automatically moves to the next letter. So we've typed in our V, and then we go to our O, J, K, L, T, U, M, oops, there we go, volume. When we're done, you push the check mark to accept your edits, and then we're going to use the arrow key to go down to the next field, which is measurement unit. And if you look at your syringe, the units are milliliters. So push the check mark to edit that field, and let's type in milliliters, M, J, K, L. And check mark to accept those changes. To leave this screen, push OK or F1. Now we are ready to go back to our graph display. We have just finished setting up for manual sampling. So home, F1 gets us back to the graph display where we still have pressure versus time. Now let's go back to our hotspots and see if we've got our volume as a data source. Push the check mark to activate them, arrow to get to them, and check mark. And sure enough, there it is, item number 2, the volume that we just defined. Select it, and now we've got pressure versus volume, and we are all ready to begin data collection. So hit the start button, and nothing seems to be happening. We want to spend all this time for that, right? Actually, if you look at the top bar, the sampling indicator is flashing at us. It is a flag flashing. That is the Explorer GLX telling us that as soon as we push the flag button, it will record a data point from the sensor and then allow us then to enter the volume. So we make sure we had our plunger at 20 milliliters to start with and hit the flag, and then we can type in 20 to tell the GLX that we want that to be 20 milliliters, and we say OK. And again, nothing seems to be happening. But look closely. Under the run number, you see your data cursor kind of flashing. Let me take this opportunity to introduce you to the move scale function on the graph display. That can be found using the F2 key or button. The first time I push it, we get the scale function, meaning I can use or we can use the arrow keys to compress or elongate the axes. If we push it again, we get the move function, which allows us to use the arrow keys to move the origin. So go ahead and push the down arrow, and sure enough, there's our data cursor. Let's go ahead and move our plunger now to 18 milliliters. Push the flag key to tell the Explorer to record that data from the sensor, and let's tell it that that is 18 milliliters and say OK. And there's our second data point. Okay, let's continue. Go to 16 and hit the flag. Type in 14. No, that was 16, sorry. 16 and say OK. And now we go to 14 and hit our flag button and type in 14 and say OK. And then drop it to 12, flag, 12, OK, final, 10, flag, 10, OK. And let's see if we can do this with the left hand on the 8. Okay, switching to the dominant hand, we go to 8, hit the flag, make sure we're there. Nope, we lost it. Type in 8, OK, and the last one, 6, and hit that flag, type in 6, and OK. And it looks like now we only have 3 data points, but if you auto scale, there is our curve. So let's go ahead and push the start stop button again to end this data run, and you see that we have a nice beautiful curve And if you're familiar with curves, this looks like an inverse proportion. And if it is truly an inverse proportion, then if we plotted pressure versus inverse volume, then we should get a nice straight line. So if we only had an inverse volume data source, you know where we're going with this, to the calculator. So home, calculator. Here we can tell the GLX that we want to create a new data source, which is inverse volume, which will be 1 divided by our volume data. So let's go ahead and turn off the numbers locks in the calculator because we want to enter in text. So edit, which is the F4, and you see that number lock is currently selected. Push the 1 key to deselect it, and now we can enter in text, which we want to call inverse I and V and space, and then we'll just call this volume VOL. You get a spelling lesson too when you take these lessons. VOL. And then equals, and we want that to be 1 divided by our volume, so 1 divided by, and then go up to our data source, which is under the F2 key, and select volume, which is item 2 on the menu. And then push the check mark, and the calculator on the bottom left of the screen tells us that our calculation is okay. So back to the graph display. Home, graph, and there's our beautiful inverse proportion, which we really don't want to lose. So let's create our new graph in a new graph page, which we can get to by accessing the graphs menu, which we can find by pushing the F4 key. And item number 6 there is our new graph page, and when that opens up we get pressure versus time. Now we know how to change time, and let's see if our new data set is in the data sources there. So select time, check mark to select it. Yeah, there it is. Item number 3, our inverse volume. We have a nice beautiful line there, and the only thing that would make this graph perfect score is if we had units on the x-axis. Go ahead and admit it. If your students turn this in, you take points off for not having units. So let's fix our graph display so that we have units. You see that we have inverse volume and then nothing there. So let's go back to our data sources. And for our inverse volume, let's select data properties, item number 5 on that menu. There we have inverse volume. Let's drop down to the next field, which is measurement unit. Push the check mark, and let's type in 1 divided by, whoops, that wasn't a 1, that was a P. PQRS 1 divided by, and milliliters, MJKL. Check mark, and we're done, so we'll say OK. And there it is, our graph, which is linear, which would imply that pressure is directly proportional to the inverse of the volume, which means that we, for ourselves, have discovered Boyle's law.